In this video, I'm going to talk about exponential and logarithmic inequality. When solving the question involving exponent or logarithm, the important thing is about the base of the exponent or the logarithm. In my previous video, I have already shown you how to solve the exponential and the logarithmic equation. So now in this video, I'm going to compare the difference when solving the equation involving exponent and logarithm and inequality involving exponent and logarithm. So now I start from the exponent. For the equation, when a power f of x equals a power g of x, since the base is the same, so we can say that the exponent f of x is equal to the exponent g of x. Now for the inequality, so the inequality based on the value of the base. If a power f of x greater than a power g of x, if the base is greater than 1, then we say that the exponent f of x is also greater than the exponent g of x. For a power f of x greater than a power g of x, if the base is less than 1, then the exponent f of x is less than the exponent g of x. Now let's try this question. Solve this exponential inequality. When solving exponential inequality, the important thing is we must make sure that the base is the same. Now on the left hand side, the base is 0.04 with the exponent 5x minus 8. Now on the right hand side, it is a fraction 1 over 25. And we know that 1 over 25, when we change to decimal, it is 0.04. So this 0.04 is the base with the exponent is 1. Now when we compare the inequality, we find that the base on the left hand side is same as the base on the right hand side, where the base is 0.04, which is less than 1. Now when we refer back to the table just now, if the base is less than 1, and if the inequality is greater than, then the exponent becomes less than. If the inequality is less than, then the exponent becomes greater than. So now for this question, since the inequality is less than and the base is 0.04, which is less than 1, so therefore the exponent 5x minus 8 is greater than or equal to the exponent 1. Then from here, we can find that x is greater than 9 over 5. Then the solution is x is greater than or equal to 9 over 5. For this question, actually there is another method. For the first method just now, we try to change the base to 0.04 for the both sides. And we know that 0.04 is equal to 1 over 25. And 1 over 25 is equal to 25 power negative 1. Now after we simplify, we find that this inequality is in the base of 25, which is greater than 1. So now when we look at the table just now, for the inequality where the base is greater than 1 and the inequality is a power f of x greater than a power g of x, then the exponent f of x is also greater than g of x. If the inequality is less than, then the exponent also less than. So now we go back to the question. Since the base is 25, which is greater than 1, and the inequality is less than or equal to, so when we move on, the exponent negative 5x plus 8 is also less than or equal to the exponent negative 1. So when we simplify, then we will get the answer same as the first method, that is x is greater than or equal to 9/5. Now let's try the exam format question. Find the set of integers that satisfy this inequality. So now first of all, I'm going to separate the exponent here. So 2 power 2 is equal to 4, and I try to keep the exponential term here, 2 power x. Now based on this expression, we find that actually this is a quadratic expression. And to make it clear, now I try to replace 2 power x with y. When we replace 2 power x with y, it is very clear that this is a quadratic expression. Then I'm going to find the range of values of y before I can find the values of x. Now to do this, from the sketch of the quadratic and the inequality is less than or equal to 0, we found that the range of values of y is greater than 1/4 and less than 3. Then now I replace back the y with 2 power x. To continue finding the values of x, now I'm going to separate this inequality into two parts. One is when 2 power x is greater than or equal to 1/4. The other one is 2 power x less than or equal to 3. Now for the first part, 2 power x greater than or equal to 1/4. 1/4 is also equal to 2 power negative 2. Now when we compare this, we find that the base is the same. And since the base is 2 and which is greater than 1, so means that the exponent x is also greater than or equal to the other exponent negative 2. Now for the other one, 2 power x less than or equal to 3. To find the values of x, now I'm going to use the logarithm. Now here I use ln. Ln is the logarithm with base e. And actually we can use any base, either base 10 or base 2. Then you will get the same result. And from here, x is less than or equal to ln 3 divided by ln 2. Since ln 3 divided by ln 2 cannot be further simplified, now I'm going to combine the set of values of x for this set 1 and set 2 in order to get the final set of values of x. To do this, I'm using the number line. This is negative 2, and ln 3 divided by ln 2, when we press the calculator, it is approximate to 1.585. So for the first set of value of x, x is greater than or equal to negative 2. Then the other one, x is less than 1.585. So now the final set of value of x is the values of x at the region where the intersection between these two set of values of x, that is from negative 2 up to 1.585. And since the question asks for the set of integers, so the solution is negative 2, negative 1, 0, and 1. Now we move on to logarithm. I start from the equation. For the equation logarithm f of x with base a equal to constant b, now to find the f of x, I shift the base of the logarithm to the right hand side, becomes the base of the exponent. So f of x is equal to a power b. Now for the inequality, if the base a is greater than 1, and if the inequality is logarithm of f of x with base a is greater than constant b, when we shift the base for the logarithm to the right hand side becomes the base of the exponent, then f of x is still greater than the a power b. But beside that, we still have to consider the range of values of x in this logarithm function, where we know that this f of x must be greater than 0. So to find the final range of value of x for the solution, we should combine these two range of values of x. Then if a is less than 1 and greater than 0, and if the logarithm of f of x with base a is greater than constant b, when we shift the base a from the logarithm to the right hand side becomes the base of the exponent, then f of x becomes less than a power b. And at the same time, we need to consider the range of values of x of f(x), which is greater than 0. Then finally combine these two range of values of x to get the final range of values of x. Now let's try this question. Solve this inequality. So to find the value of x, first I'm going to shift the base of the logarithm to the right hand side, becomes the base of the exponent. And because this base is 0.5, which is less than 1, so when we shift the base to the right hand side, then the inequality here will change, becomes less than, which is 2x plus 54 will be less than 0.5 over negative 2. And 0.5 power negative 2 is 4. So now when I simplify, I'll get x less than negative 25. This is not the final answer because we still need to consider the range of values of x under the logarithm function here. And we know that the logarithm function 2x plus 54 must be greater than 0. So now from here, when we simplify, x is greater than negative 27. So now we are going to combine these two values of x. When we use the number line, and the first x is less than negative 25, but not included negative 25. Then the second one, x is greater than negative 27, but not equal to negative 27. So the final range of values of x should be the values of x where there is an intersection between these two arrows. So therefore, the final solution should be the values of x in between negative 27 up to negative 25. Therefore, this is the final solution for this inequality. Now let's try this question. Solve this inequality. For the loan, we know that loan is logarithm with base e. And e is a constant approximate to 2.718. Now to find the value of x, I'm going to shift the base e from the logarithm to the right hand side, becomes the base of the exponent. And since the value of e is greater than 1, which is 2.718, so Now, this inequality is same as this one. So from here, we know that e power 0 is equal to 1. So finally, we get x greater than negative 1. And this is not the final answer because we need to consider the logarithm function where 2x plus 3 must be greater than 0. Now we know that x must be greater than negative 3 over 2. Then I'm going to combine these two range of value of x in order to get the final answer. So from the number line, when x is greater than negative 1 but not included negative 1, and for the second, the x is greater than negative 3 over 2 but not included negative 3 over 2. So the final range of values of x is where there is the intersection between these two arrows. That is, x is greater than negative 1 but not included negative 1. So therefore, the solution for this inequality is x greater than negative 1. Now we move on. First, for the equation of the logarithm, when log of f of x with base a is equal to log of g of f with base a, if the base is the same, then f of x is equal to g of x. Now for the inequality, if the base is greater than 1, and if the inequality is logarithm of f of x with base a is greater than logarithm g of f with base a, and if a is greater than 1, then f of x is also greater than g of x. But at the same time, we must consider the values of x in the f of x and the values of x in g of x, because we know that the logarithm f of x and g of x must be greater than 0. Then after that, we combine these three values of x in order to get the final range of values of x. Now if a is less than 1 but greater than 0, and if logarithm f of x with base a is greater than logarithm g of x with base a, then f of x should be less than g of x, which is opposite from the original inequality. Then at the same time, we still need to consider f of x and g of x under the logarithmic term, where f of x and g of x must be greater than 0. Then we combine these three range of values of x to get the final solution. Now let's try this question. Solve this inequality. So notice that the logarithm on the left hand side and right hand side, there is ln. And we know that ln is the logarithm with base of e. And e is a value 2.718, which is greater than 1. So since the base is the same on the left hand side and on the right hand side, and the base is greater than 1, so this means that x plus 2 is also less than 2x minus 6. Then from here, we will get x greater than 8 for the first range of values of x. Then after that, this is not the final answer because we still need to consider the range of values of x in the logarithmic term on the left and on the right. So for the first one, x plus 2 must be greater than 0. And from here, x is greater than negative 2. 2x minus 6 is greater than 0. And then x is greater than 3. Now to find the final solution, I'm going to combine these three range of values of x. So to do this, I'm going to use a number line. And for the first one, when x is greater than 8 but not included 8. The second one, x is greater than negative 2, not included negative 2. And the third one, x is greater than 3 but not included 3. So the final solution should be the range of values of x where there is the intersection between these three arrow lines. So therefore, the final solution should be x greater than 8 and not equal to 8. So therefore, the solution is x greater than 8. Now let's try this question. This inequality, since the base is the same on the left hand side and on the right hand side, and the base is 0.5 which is less than 1, so when we cancel off the logarithm, then x plus 2 should be greater than 2x minus 6, which is the opposite direction from the question. So now from here, x is less than 8. And this is not the final answer because we still need to consider the values of x in each of the logarithmic terms on the left and on the right. So for the first one, x plus 2 should be greater than 0, then x should be greater than negative 2. Then 2x minus 6 should be greater than 0, and finally x greater than 3. Now to find the final answer, I'm going to combine these three values of x. From the number line, when x is less than 8 and not included 8, the second one, x is greater than negative 2 and not included negative 2. Then x is greater than 3 and not included 3. So the final solution should be the values of x in the region where there is the intersection between these three arrows. So now we find that the intersection area is from 3 to 8 and not included 8, not included 3. So therefore, the final solution for this inequality is from 3 to 8. Now, after the basic question, now we are going to try some exam format question. Now, for this question, solve the inequality. To solve this inequality, first, we must make sure that the base of the logarithm should be the same. So now the base is 0.5. Now I'm going to combine these two logarithmic terms. To do this, I shift the 2 on top here, down in front becomes 2 log x. So when 2 log x plus 1 log x, that is 3 log x, and I shift the 3 to the other side. Then log x with base 0.5 is less than or equal to 1. To find the range of values of x, I need to shift the base of the logarithm here to the right hand side, becomes the base of the exponent. Now since the base is 0.5 which is less than 1, so when I shift, then the inequality here should be changed to greater than or equal to. So then I get x is greater than or equal to 0.5 power 1. So therefore, the final solution for this inequality is x is greater than or equal to 0.5. Now another exam format question. Solve this inequality. Now when solving question involving logarithm, first thing I must double check whether the base is the same. So notice that the base is different. One is base 5 and the other one is base x. So now I'm going to change this term into base of 5 such that the base is the same. Now by using the law of logarithm, when I change to base 5, this one becomes logarithm 1 to 5 with base 5 divided by logarithm x with base 5. And we know that logarithm 1 to 5 with base 5 is equal to 3. And in order to make this inequality becomes the easier one, now I try to replace y with logarithm x with base 5. So after I replace, I'll get this one where I can see that the inequality becomes easier. Now to solve this inequality, based on what we have learned in inequality, if the denominator is an unknown, we are not allowed to do any cross multiplication. So to do this, I'm going to shift the 1 to the left hand side and simplify this one becomes a single fraction. That is the rational form. To find the range of values of y here, now I'm going to test the sign of each of the factor here under a number line. So, for the first factor, 2y minus 3, when the y value is less than -1, and we find that 2y minus 3 is negative. When y value is between -1 to 0, 2y minus 3 is negative. When y is between 0 to 3 over 2, 2y minus 3 is negative. And when y is greater than 3 over 2, 2y minus 3 is positive. For the second factor, y plus 1, when y is less than -1, y plus 1 is negative. When y is in between -1 to 0, y plus 1 is positive. When y is from 0 to 3 over 2, y plus 1 is positive. And when y is greater than 3 over 2, y plus 1 is positive. For the third factor, y, for y less than -1, it is negative. Less than 0, negative. Greater than 0, positive. So now I'm going to combine all the signs for these three factors. For the values of y which is less than -1, we will get negative. This one, positive. This one, negative. And finally, positive. Then since from the inequality should be less than 0, so the range of values of y, then we will take the values of y where the answer is a negative. So therefore, from this table, we found that y should be less than -1 and also y should be greater than 0 but less than 3 over 2. After I have got the set of values of y, now I replace back y with logarithm x with base 5. Now for this one, to find the values of x, I'm going to shift the base of the logarithm to the right hand side becomes the base of the exponent -1. So since the base is 5, which is greater than 1, so when I shift the base, the inequality is still less than. So I get the first set of value of x, which is x less than 1 over 5. For the other set of values of x, for this one, I'm going to separate into two. One is log x base 5 greater than 0, and the other one is logarithm x with base 5 less than 3 over 2. For this one, to find the x, I shift the base of log to the right hand side, and since the base is greater than 1, so I keep the inequality greater than, so x greater than 1. And for this one, when I shift the base 5 to the right hand side, I get x less than 5 power 3 over 2. So 5 power 3 over 2 is 5 square root of 5. And when I combine back this set of values of x, I find that x is greater than 1 and at the same time x is less than 5 square root of 5. So this is the second set of values of x. Then now I'm going to combine these two sets of values of x. That is, one is less than 1 over 5. The other one is in between 1 to 5 square root of 5. And I'm going to use the number line to do this. So for the first one, x less than 1 over 5. Since we know that logarithm of x, where x must be greater than 0, for the inequality x less than 1 over 5, the values of x is up to 0 and not included 1 over 5. For the second set of values of x, which is greater than 1 and less than 5 square root of 5, not included 1, not included 5 square root of 5. And since we combine these two sets of values of x with r, so therefore the final solution is x is greater than 0 but less than 1 over 5, or x is greater than 1 but less than 5 square root of 5. I think that's all for now. If you feel that this video is beneficial, please hit the like button. Thanks for watching.